Welcome to the Sleepy Astronomer. I'm so glad you're here. As the stars rise in your sky, take a moment to settle in, breathe deeply, and let your mind drift into the gentle rhythms of the cosmos. Where in the world are you watching from tonight? Whether you're nestled under northern skies, listening by the ocean, or cozied up in a quiet room far from city lights, this space is for you. Tonight, we're exploring a curious question that sounds simple, but opens a door to wonder. What is a light year really? Let's float slowly through space and time together. Close your eyes if you like. The stars are waiting. Light. We often take it for granted. It pours through our windows in the morning, dances across the surface of lakes and leaves, flickers from distant stars, and glows softly from the moon. But what is light really? At its most fundamental level, light is energy. Not just any kind of energy though, it's electromagnetic radiation. That might sound technical, but imagine ripples moving through an invisible ocean. These ripples, or waves, are light, travelling through space without needing a medium, no air, no water, no wires, just energy gliding silently through the void. Light behaves both like a wave and like a particle. Scientists call this strange behaviour wave-particle duality. It means that in some experiments, light spreads and bends like waves do on the surface of water. In others, it arrives in tiny packets called photons, like little messengers, each carrying a bit of energy. This dual nature is one of the most mysterious and beautiful aspects of physics. Imagine you're holding a flashlight in the darkness. The beam that stretches out before you is made of photons, travelling outward in perfectly straight lines, unless they're bent by a mirror, a lens, or gravity itself. Yes, gravity can bend light. Massive objects like stars or black holes can pull on the path of light, curving it ever so gently. It's a phenomenon called gravitational lensing, and it's one of the ways we see the invisible by watching how light warps around things too dark to see. Light doesn't just travel fast, it travels at the fastest possible speed in the universe. In fact, nothing we know of moves faster. Light blazes across the vacuum of space at 299,792 kilometers per second, or about 186,282 miles per second. To help picture that, think of this. In just 1 second, a beam of light could circle the entire Earth more than 7 times. That's fast enough to make time feel like it stands still. And for light, in a sense, it does. From a photon's point of view, it experiences no time at all between leaving a star and arriving in your eye. But light isn't all the same. It comes in many forms. The light we can see with our eyes is just a tiny sliver of what scientists call the electromagnetic spectrum. On one end, you have long, lazy radio waves that can pass through buildings. Then there are microwaves, warming your food, or bouncing from satellites. Beyond that, infrared light, gentle warmth, like the heat of a campfire. The visible light spectrum follows, everything from deep red to vibrant violet. Beyond violet comes ultraviolet, the kind of light that gives you a sunburn. Then even higher energy, X-rays peering into your bones. And finally, gamma rays, the most powerful, dangerous form of light released in the universe's most violent explosions. But all of them, radio waves, microwaves, X-rays, visible light, are still the same thing. Photons moving at the speed of light, carrying energy. What changes is their wavelength? Imagine stretching a slinky back and forth. Long, smooth waves are low energy light. Short, rapid waves are high energy. The difference between a soothing beam of red light and a cancer-causing gamma ray is just how tightly those waves are packed. Light is more than just a physical phenomenon. It's how we see the universe. Everything we know about distant stars, about galaxies too far to ever touch, comes from light. No spaceship has ever travelled to the Andromeda Galaxy, and likely never will. Yet we know it's there. We know what it's made of. We know how fast it's moving. All of that from the ancient light that took over 2 million years to reach us. Even in everyday life, light is always revealing. It paints the colours of the world around you. When sunlight strikes a leaf, the green you see is what's not absorbed. That shade is reflected back to your eyes, while the rest becomes food for the plant. The blue of the sky, that's sunlight scattered by air molecules spreading shorter wavelengths like blue and violet in every direction. Light also gives rhythm to our days. Circadian rhythms, the internal clocks in our bodies, are synced to the rising and setting of the sun. Morning light tells our brains to wake up. The fading golden hues of sunset whisper that it's time to rest. Even sleep, the very state you're slipping into, is tied to the coming and going of light. And yet the light we see is only a tiny fraction of what exists. Beyond human sight, bees see in ultraviolet. Snakes can sense infrared heat. Our world is filled with hidden light, humming silently all around us. So when we ask, what is a light year? We're really asking, how far does this strange, ancient traveller go in a year? But before we can measure that, we must understand the traveller itself, light, the cosmic messenger, the oldest whisper in the universe, the silent runner carrying secrets from stars, stories from the birth of galaxies, memories from a time before Earth was born. And so, as you close your eyes and listen, remember that even in darkness, light is still moving, always moving, through space, through time, through you. Imagine, for a moment, that you are standing on the edge of a vast and silent field, one so large it has no visible end. You hold in your hand a beam of light, like a delicate ribbon of energy, ready to be released. And when you let it go, it vanishes in an instant, racing forward at the fastest speed anything in the known universe can travel. Light travels at 209,792 kilometers per second. That's about 186,282 miles per second. It's such a large number that, honestly, it becomes difficult to imagine. Our brains are used to thinking in walking pace, driving speed, or even jet planes. But light leaves all of that in the dust. It's a kind of cosmic speed limit, the fastest that information, energy or matter can move through the fabric of reality. Not just a fast thing, the fastest thing. To understand this speed more clearly, it helps to scale it down into something familiar. Take Earth, for example. Our planet is roughly 40,000 kilometers in circumference. If you could ride a beam of light around the Earth, you'd circle it almost 8 times in a single second. blink, and the light is already gone, racing far beyond the curve of the planet. Now look up. The light from the moon takes just 1.3 seconds to reach your eyes. That means when you gaze at a full moon, you're seeing it not as it is now, but as it was just over a second ago. It's not much, but the delay is there. From the sun, 8 minutes and 20 seconds. That's how long it takes for sunlight to travel the 150 million kilometers from the center of our solar system to us. So, if the sun were to suddenly disappear, don't worry, it won't. We wouldn't know for over 8 minutes. Everything we see is just a little bit in the past. And yet, for all its speed, light can feel incredibly slow when measured across the vast, mind-bending scales of the universe. Even at nearly 300,000 kilometers per second, light takes over 4 years to reach us from the nearest star beyond our sun, Proxima Centauri. That's 4 years of non-stop, uninterrupted movement through the black, silent void of space. Let's try to slow down this idea even further. Say you had a spaceship that could somehow travel at the speed of light. If you left Earth and headed toward Proxima Centauri, it would still take you over 4 years to arrive, if you weren't slowed by time or gravity or the limits of physics. And remember, that's to the nearest star. Most stars are hundreds, thousands, even millions of light years away. Light, while impossibly fast to us, becomes almost patient and steady on cosmic scales. A quiet traveller with a long journey ahead. But here's something even more wondrous. Time changes at the speed of light. According to Einstein's theory of relativity, the faster you move, the more time slows down for you compared to someone standing still. As you approach the speed of light, time begins to stretch. And at the speed of light itself, time, for the light, stops entirely. From a photon's point of view, there is no passage of time between the moment it is born and the moment it is absorbed. A beam of light could travel for billions of years across the universe, but to the photon itself, no time has passed. It simply exists, moving forward, timeless and eternal. This is why physicists often call the speed of light not just a speed, but a universal constant. It's built into the very structure of the universe. Equations like Einstein's famous E equals mc2 rely on it. It connects energy and matter. It defines how space and time interact. It limits how fast we can send messages, how far we can travel, and how quickly we can see the universe as it is. Even when we communicate with spacecraft, like the rovers on Mars, we're limited by this cosmic speed. When scientists on Earth send a command to a robot on the Martian surface, it takes anywhere from 5 to 20 minutes to arrive, depending on the positions of the planets. The rover then processes the instruction and sends a signal back, which takes another 5 to 20 minutes. In other words, real-time conversations across space are impossible. The speed of light sets a delay we cannot escape. And still it's incredible. A message, a signal, a moment of warmth on your skin, travelling across unimaginable distances, carried by light. Even now, light is moving all around you, through your room, through the atmosphere, through the vast, dark ocean of space. Light is whispering stories from distant stars, from galaxies millions of years older than Earth itself. When you gaze up into the night sky and see a star twinkle, remember, the light you're seeing may have travelled for thousands of years just to reach you. That beam of light has avoided collisions, outpaced every object in the universe, and waited through the centuries to arrive, gently, into your eye. It moves so fast that nothing can catch it, and yet, in its swiftness, it becomes the most faithful historian of the cosmos. Because of light's speed, its incredible, fixed, unchangeable speed, we don't just look into space when we gaze at the stars. We look into the past. So when we talk about the speed of light, we're not just talking about velocity. We're talking about memory, time, space, the structure of reality itself. Light is not only fast, it's foundational. And as you begin to rest, let your mind travel with it. No effort, no motion, no urgency. Just light gliding calmly across the heavens, always moving, always reaching, carrying the ancient story of the universe, 1 second, 1 heartbeat, 1 shimmering instant at a time. Let's imagine a journey together, a quiet, gentle trip through the vastness of space. Not too far, not to the edge of the galaxy or a distant star, but somewhere much closer. A place we can see on clear nights with our own eyes. A pale, glowing companion that follows us across the sky. Let's travel from Earth to the Moon, carried only by a beam of light. The Moon feels close to us. We see it almost every night, shifting in shape, glowing with soft reflected sunlight. It pulls at the oceans, guiding the tides. It lights our paths at night. Poets have written about it for centuries. Lovers have stared at it together in silence. And yet, even this nearby neighbour floats in a vast, silent void, and the space between us is wider than it first seems. On average, the Moon is about 384,400 kilometres away from Earth. That's roughly 238,155 miles. To drive that distance in a car at highway speed, say 100 kilometres per hour, it would take you more than 160 days, driving non-stop, day and night, without resting. By plane, you'd still need around 19 days of constant flying. But light? Light covers that distance in just 1.28 seconds. Less than 2 seconds. That means when you look up at the Moon, you're not seeing it as it is right now. You're seeing it as it was a second and a quarter ago. That glow, those beams of silver and white, they were reflected from the sun, bounced off the Moon's surface, and spent just over 1 second crossing the gap between worlds before gently touching your eyes. Let's slow this moment down. Picture a single photon, a tiny packet of light, leaving the Moon's surface. Maybe it's bouncing off a crater rim, or a ridge of ancient dust where an astronaut once walked. That photon launches into space at 209,792 kilometers per second. It passes silently through the vacuum, untouched, unbothered. No wind, no sound, just darkness and silence. At the same time, on Earth, you're lying down, perhaps with eyes half closed, gazing at the night sky. That tiny photon continues its short journey, zooming across the Earth-Moon distance in just over a second, and then it reaches you. It touches your retina, and your brain turns it into vision. Without you even thinking about it, You're now connected to an object that floats hundreds of thousands of kilometers away. There's something humbling about that, something soft and mysterious. The moon's light is borrowed. It reflects the sun's rays like a mirror. The surface of the moon is dusty and grey, made of fine rock and powdered minerals, pitted with ancient scars from meteor impacts. When sunlight strikes this surface, most of it is absorbed, but a portion bounces back into space, and some of those reflected rays make their way to Earth. Because of this reflection, moonlight is much dimmer than sunlight, about 400,000 times dimmer. But our eyes are sensitive. In the quiet stillness of night, they adjust to darkness. The moon doesn't shine, not really. It glows like the memory of a brighter light. During a full moon, Earth is perfectly positioned between the sun and the moon. Sunlight hits the moon's entire face and reflects back at us in full. During a new moon, the moon is between the sun and Earth, and we see only shadow. But even then, a faint ghost of light can sometimes be seen, earthshine, light from the sun reflected off Earth, bouncing to the moon, and back again. It's like a gentle game of cosmic catch, with photons as the ball. The moon's surface isn't smooth. It's covered with mountains, valleys, old lava plains called Maria, and vast impact basins. As light reflects off these different textures, it creates the subtle shadows and highlights we see with the naked eye. When you look closely, perhaps with binoculars or a telescope, you can make out the intricate landscape. And again, remember, all of this detail reaches you through light that took just over a second to arrive. In the grand scale of the universe, 1 second is nothing. But in the human mind, it's a moment we can grasp, a heartbeat, a breath, a blink. That's the time it takes for a beam of light to cross the space between Earth and its moon. So close, and yet still separated by hundreds of thousands of kilometers. Think about communication. When astronauts landed on the moon in 1969, their voices were sent as radio waves, another form of light, back to Earth. That means there was always a slight delay. When mission control spoke, it took just over a second to reach the astronauts. When the astronauts replied, it took another second to return. A round-trip delay of about 2.5 seconds. Not long, but just enough to feel the space between two worlds. This tiny delay reminds us, even our nearest neighbour floats far away, held in balance by gravity, drifting through the silence of space. The moon doesn't orbit Earth in a perfect circle. It travels in an ellipse, meaning its distance changes slightly. Sometimes it's a little closer, sometimes a little farther. That's why the moon appears slightly larger or smaller in the sky at different times of the month. And when there's a lunar eclipse, Earth passes between the moon and the sun, casting its shadow across the moon's surface. Even this dance of shadows happens at the speed of light. What we see, the slow darkening of the moon, is shaped entirely by how light moves, how it bends, how it's blocked, how it finds its way to us. So next time you see the moon rising above the trees, take a moment to reflect. It's not just a rock in the sky, it's a time machine. The light you're seeing is not of the present, but of the past. A second and a quarter ago. A snapshot. A silent gift from space, and all of it delivered by light, moving faster than anything else in the universe, yet still needing just a little time to reach you. As you drift off to sleep tonight, let your thoughts travel with that beam of light, from Earth to the moon. A quiet, gentle arc through the stars, through the darkness, through the calm and quiet of the universe. A journey of just over 1 second, but a journey full of wonder. Let's turn our gaze to a different kind of light. Not the cold, distant glow of the moon, but the warmth that touches your skin on a bright summer morning. The golden light that streams through your window as you slowly wake. The light of the sun, our star, our life giver, our constant companion in the sky. It's easy to forget that the sun is just another star, not the largest, not the brightest, not the oldest. But to us, it's everything. It shines with a steady brilliance, lighting our days, warming our planet, fueling the growth of every tree and blade of grass. But here's something strange. The sunlight that warms you right now isn't actually now. It's old, not ancient, like the light from distant stars, but still delayed. It took a journey to get here. On average, the Earth is about 150 million kilometers, or 93 million miles, away from the sun. At the speed of light, that journey takes about 8 minutes and 20 seconds. This means that every time you feel sunlight on your skin, it left the surface of the sun eight minutes ago. In other words, the sun you see in the sky is not the sun as it is. It's the sun as it was 8 minutes earlier. If the sun were to suddenly vanish, you wouldn't know right away. The sky wouldn't go dark. The world wouldn't grow cold. Not instantly. For just over 8 minutes, everything would appear perfectly normal. And then, all at once, we'd know. But the story of sunlight doesn't begin on the sun's surface. It begins much, much deeper. Deep inside the sun's core, more than 500,000 kilometers below the surface, unimaginable pressure and heat create the perfect environment for nuclear fusion. Hydrogen atoms, squeezed together under extreme conditions, fuse to form helium. In the process, energy is released, tremendous amounts of energy, in the form of gamma rays, a type of high-energy light. But these photons, these newborn beams of light, don't leap straight out into space. No, their journey begins in chaos. The inside of the sun is dense, unbelievably dense. A photon, created in the core, can travel just a tiny fraction of a millimeter before crashing into another particle. It ricochets in a random direction, only to be absorbed, re-emitted, and scattered again. This process, known as the random walk, means that a single photon can take thousands to millions of years to make its way from the sun's core to the surface. That's right. The light you see today may have been born in the heart of the sun long before the first humans walked the earth. Eventually, after a long chaotic journey, these photons reach the sun's surface, the photosphere. From there, they're finally free. No more collisions, no more scattering. At last, light bursts outward into space, travelling in all directions, including toward Earth. And once it escapes, that's when the clock starts. From the surface of the sun to Earth, it's a straight shot, a clean run, 8 minutes and 20 seconds of uninterrupted flight through the vacuum of space. During that time, Earth keeps spinning, orbiting gently. Clouds drift. People walk, talk, bonsoir, and then, right on time, the light arrives. It slips into our atmosphere, some of it scattering into brilliant blue sky, some bouncing off clouds, some absorbed by the ground, and some landing softly on your skin. Have you ever felt that sudden warmth when a cloud moves aside and the sun returns? That glow, that feeling of golden heat on your face? That is light, over 8 minutes in the making. A moment that began long before you noticed it. A silent gift sent across the solar system. Sunlight isn't just heat, it's full of energy. Energy that plants transform into life. Through photosynthesis, leaves capture the sun's light and use it to build sugar, to grow every tree, every fruit, every flower, every breath of oxygen, all born from that journey of light. The food we eat, the air we breathe, it's all tied to those tiny beams of light that left the sun minutes ago and started their journey millions of years before that. And it's not just life that sunlight touches. It shapes time. The rising and setting of the sun gives us our days. Its path across the sky marks the hours. Before clocks, people watched shadows stretch and shrink to know the time. Even now, our internal rhythms, our circadian cycles, are synced to the light of the sun. We wake when it rises. We grow tired when it fades. Sunlight also changes. In the early morning and late evening, when the sun is low in the sky, its light must pass through more of Earth's atmosphere. Shorter wavelengths, blue and violet, scatter away, leaving behind the long, slow waves of red, orange and gold. That's why sunrises and sunsets feel so soft, so peaceful. The light has been stretched and scattered, painted across the sky in colours that feel like dreams. And during an eclipse, when the moon passes between Earth and the sun, we are reminded just how powerful and fragile sunlight really is. In those brief moments of shadow, birds fall silent, the air cools, the world holds its breath. And then, just as quickly, the light returns, and with it, a feeling of wonder. So when you see sunlight pouring through the trees, when you watch golden reflections shimmer on the surface of a lake, remember this. What you're seeing is not happening now. It happened 8 minutes ago. The light you're experiencing is old. It's travelled across vast emptiness to find you. It's the result of atomic reactions deep in a star, scattered for millennia, finally set free, finally reaching you. It warms your skin, brightens your world, and quietly tells a story that began long before you noticed it. Light, born in the heart of a star, moving at the universe's speed limit, carrying with it the energy of life, the rhythm of days, and the beauty of time itself. So close your eyes, feel its warmth, and imagine that ancient journey from the heart of the sun to you. When we say the words 1 light year, it might sound like we're talking about a unit of time. After all, a year is a measure of how long the Earth takes to circle the sun once. But surprisingly, a light year is not about time at all. Instead, it's a measure of distance. It's a way astronomers use to describe the vast, almost unimaginable spaces between stars, galaxies and everything else in the universe. To truly grasp what a light year is, we must begin with the traveller itself, light. Light moves incredibly fast, about 209,792 kilometers per second. Now imagine letting that light run free, unimpeded, for an entire year. A whole Earth year, with all its days and nights, seasons changing, and time flowing steadily forward. A light year measures exactly how far light travels during that span of time. It's easier to understand if we break it down piece by piece. First, think about how many seconds there are in a year. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and roughly 365.25 days in a year, accounting for leap years. Multiply all of those together, and you get about 31,557,600 seconds in a year. That's a lot of seconds ticking quietly away. Now, because light travels at nearly 300,000 kilometers per second, in each of those seconds it covers a vast distance. If you multiply the speed of light by the total number of seconds in a year, you find that light travels roughly 9.46 trillion kilometers in a single year. Put another way, that's about 5.88 trillion miles. It's a number so large it's almost impossible to picture. To bring this staggering distance closer to home, imagine driving a car on Earth's highways at a steady speed of 100 kilometers per hour. To cover 1 light year, it would take you over 100 million years of non-stop driving. Every hour, every day, every year, without rest or pause, until more than 100 million years had passed. That's how far light travels in just 1 year. So when astronomers say a star is 10 light years away, they mean that the light we see from that star has travelled 10 times that unimaginable distance to reach us. The star is so far that even light, the fastest thing in the universe, needs a whole decade to make the journey. Light years help us navigate the cosmic ocean. Because distances in space are so vast that measuring them in kilometers or miles becomes unwieldy and nearly meaningless to our minds. Saying a star is 50,000 kilometers away is not only cumbersome but almost impossible to grasp. Using light years allows us to think in a way that connects distance with the passage of time and the speed of light itself. This unit is deeply poetic in a way. When we look at stars that are hundreds or thousands of light years away, we're not just seeing distant points of light, we're looking back in time. We're seeing the stars as they were hundreds or thousands of years ago, because their light has been travelling to us silently and steadily for all that time. In a very real sense, a light year is both a measure of distance and a time capsule. It's important to understand that a light year isn't about how long it takes to travel somewhere for us, like a trip you might take on a plane or a train, but about the distance light itself covers in that time. Even with the fastest spacecraft humans have ever built, reaching something even 1 light year away would take tens of thousands of years. Light years give us a way to communicate these vast distances clearly, to stretch our minds beyond the boundaries of Earth and the solar system. They help scientists explain the size of galaxies, the space between star systems, and the scale of the universe itself. The beauty of the light year is that it ties together space and time in a single, elegant measure. When we say something is a certain number of light years away, we're not only telling you how far it is, we're telling you how long its light has travelled through the universe to reach us. This means when you look up at the night sky and see a star shining, you're actually looking at a beacon from the past. The light you see might have begun its journey hundreds, thousands, or even millions of years ago, travelling silently through the darkness to find your eyes. This journey of light is like a quiet messenger, carrying stories from distant corners of the cosmos across vast expanses of space and time. Each light year is a link in the chain, a stretch of space travelled by this messenger, who moves tirelessly and relentlessly at the speed of light. So, a light year is more than just a number or a unit. It's a measure of the universe's grandeur. It's a reminder that the cosmos is immense beyond imagination, yet connected by the steady, faithful flight of light. When you understand what a light year really means, you begin to see the universe not just as a distant void, but as a vast, interconnected web of light, time and space, woven together in an eternal cosmic dance. And as you rest your eyes, you might imagine yourself floating among those beams of light, carried gently across billions of kilometers, crossing time itself, moving with the universe's most ancient traveller. The idea of a light year is awe-inspiring, but the sheer size of it can be difficult to truly grasp. When we say that a light year is about 9.46 trillion kilometres, or roughly 5.88 trillion miles, those numbers are so enormous they almost lose meaning. Our minds, accustomed to the scales of everyday life, struggle to picture distances so vast. So, let's take a slow, gentle journey to better understand what this distance really means, by comparing it to things we know, and letting our imagination stretch comfortably into the vastness of space. First, let's consider the Earth. The circumference of our planet is about 40,000 kilometres. To travel a full circle around the Earth, a beam of light would take just about 0.1 seconds. That's a tiny blink of an eye. Now imagine travelling around the Earth not once, but about 236 million times. That's roughly how many times light can circle our planet in a single year. It's like a marathon race that never ends, with light sprinting effortlessly day and night with no breaks. If you wanted to drive this same distance by car, assuming a steady speed of 100 kilometers per hour, without stopping, it would take you over 9.5 million years to cover the distance light travels in just 1 year. That is a time span that stretches far beyond the history of human civilization. To put it gently, it's a length so immense that thinking about it invites a sense of quiet wonder and deep humility. Now, let's think about something a little bigger, the distance between Earth and the Sun. As mentioned before, light takes about 8 minutes and 20 seconds to cover the 150 million kilometers between the Sun and Earth. This means that 1 light year contains about 63,241 trips from the Earth to the Sun. Imagine making that trip 63,000 times in a row without stopping. That's the scale of 1 light year. Another way to explore this is by thinking about space travel. The fastest spacecraft humans have ever built, like the Parker Solar Probe, can travel at speeds of roughly 700,000 kilometers per hour. Even at this extraordinary speed, it would take the probe over 1,300 years to travel a single light year. And remember, the nearest star beyond the Sun is more than 4 light years away. The distances are vast and humbling beyond measure. When we expand our view beyond our solar system, the scale grows even more staggering. The nearest star system to us, Alpha Centauri, lies approximately 4.37 light-years away. That means the light we see from Alpha Centauri tonight actually left that star over 4 years ago. The light has travelled steadily across the void, across the vast gulf of space, crossing trillions upon trillions of kilometres to reach our eyes. The stars that populate our night sky are, in reality, distant suns scattered across immense distances. Their light can take dozens, hundreds, even thousands of years to reach us. Some stars we see are long gone, extinguished in cosmic terms, yet their light continues to journey, quietly and patiently, across the expanse of space. Even entire galaxies are measured in millions or billions of light years. Our own galaxy, the Milky Way, spans about 100,000 light years across. That means light would take 100,000 years to travel from one edge of the Milky Way to the other. Beyond the Milky Way lie countless other galaxies, some billions of light years distant. When we observe these galaxies through powerful telescopes, we are looking deep into the past, peering back billions of years in time. The immensity of a light year stretches our understanding of distance and time. It invites us to see space not as empty, but as a vast, interconnected ocean of light and time, with distances so immense that even the fastest traveller, light itself, needs years to cross them. To help bring this closer to a feeling you can hold softly, try this. Imagine the distance between you and a close friend standing just a few meters away. Now stretch that distance 1,000,000 times, then 1,000,000,000 times. Each stretch is like adding another piece to the cosmic tapestry, and before long, you find yourself moving beyond human scale into the vastness of space. And yet, despite this immensity, the light year remains a helpful tool, a way to give shape to the void, to measure the unreachable, to put gentle numbers around the incomprehensible. It allows astronomers to map the universe, to communicate distances, and to share the grand stories told by the light reaching us from the depths of space. As you rest with this thought, let your mind wander with the light itself. Let it race and circle, stretching around planets, stars, and galaxies. Imagine the quiet persistence of light as it travels its endless journey through the silent night, connecting distant corners of the cosmos in a delicate thread of shimmering energy. And as you drift deeper into calm, remember, the light you see in the night sky has travelled an extraordinary distance, crossing 9.46 trillion kilometres for every light year. A distance so vast that it stretches beyond time and space as we know them, inviting us to dream beyond the limits of our everyday world. When we think about the universe, it's easy to imagine distant stars as unreachable points of light, cold and mysterious, far beyond our everyday experience. But some of these stars are actually part of our cosmic neighbourhood, relatively close companions shining quietly not too far from our own sun. Exploring these nearby stars in terms of light years helps us bridge the gap between the familiar and the vast unknown, bringing the grandeur of space just a little closer to home. Our nearest stellar neighbour is a trio of stars called Alpha Centauri. This fascinating system lies about 4.37 light years away. That means the light from Alpha Centauri takes just over 4 years to reach us here on Earth. In human terms, 4 years might feel like a blink, a short chapter in a lifetime, but in cosmic terms, it's a gentle reminder of the immense distances that separate us even from the closest stars. Alpha Centauri isn't just one star, it's a family. Two of them, Alpha Centauri A and Alpha Centauri B, dance together in a slow, gravitational embrace. A third, smaller and dimmer star called Proxima Centauri orbits the pair at a much greater distance. Proxima Centauri holds a special place in the hearts of astronomers because it's the closest individual star to us, at about 4.24 light-years away. To put that in perspective, the light that glimmers from Proxima Centauri left that star long before the year 2020. It's been travelling steadily across the cosmic ocean through the emptiness of space before arriving at Earth just recently. The photons that enter your eye now are echoes from the past, messages sent across years and trillions of kilometres. Proxima Centauri is a small, cool red dwarf star, much dimmer than our Sun. Despite its faintness, it has drawn great interest because it hosts at least one known planet within its habitable zone, a region where temperatures might allow liquid water to exist. This raises exciting possibilities about worlds beyond our solar system. The next star in our neighbourhood is Barnard's star, located about 6 light-years away. Barnard's star is a faint red dwarf as well, moving across the sky faster than any other known star relative to the Sun. Though it's invisible to the naked eye, it has been a target of many searches for planets and remains an intriguing point of light in the darkness. Further out, the famous bright star Sirius shines at about 8.6 light-years distance. It's the brightest star in our night sky, a dazzling beacon with a companion white dwarf star orbiting nearby. Sirius is a favourite of stargazers and storytellers alike, often called the Dog Star, due to its place in the constellation Canis Major. Its light is a brilliant gift, travelling across nearly 9 years of space to reach us. Even though these stars are relatively close by cosmic standards, the distances involved are still vast beyond human scale. Think of the distance between Earth and the Sun, about 8 light minutes. Even that seems large in everyday terms, but now multiply that distance by tens or hundreds of thousands, and you begin to approach the distances to these nearby stars. The light year helps us understand this grand scale in a way that feels both manageable and poetic. It's not just a measurement, it's a bridge. When we say a star is 4 light years away, we're telling a story about distance and time, about light travelling patiently through the void, and about the universe reaching out to us. Our neighbourhood stars remind us that while space is vast and often empty, it's also full of companions. Each star is a sun, potentially with planets, moons, and maybe even life. And their light, travelling those light years, is the thread that connects us to those distant worlds. Astronomers use powerful telescopes and precise instruments to study these nearby stars and their planets. They analyse the light that reaches us, breaking it down into spectra, searching for clues about composition, atmosphere, and even signs of life. Each photon carries secrets, whispers from these faraway suns. Imagine yourself standing beneath the night sky, looking toward Alpha Centauri or Sirius. The light you see is a gentle traveller, crossing vast distances at incredible speed, weaving the cosmic tapestry that links us all. Though those stars seem like tiny points of light, they are enormous suns, with their own histories and stories. Even more, When we imagine someday sending spacecraft to these neighbours, an idea that sparks wonder and dreams, we confront the immensity of these distances. Travelling just a few light years requires technology far beyond what we have now, patience spanning generations, and a sense of scale that humbles even the most ambitious explorers. Yet despite their remoteness, these stars form our closest cosmic family. Their light reaches us year after year, century after century, telling us of their presence and inviting us to look up and dream. So as you relax under the sky tonight, think of these stars near enough to be called neighbours, and yet so distant that their light is a journey through time itself. Let their quiet glow inspire a sense of connection to the universe, to the past, and to the endless possibilities waiting beyond the night. Measuring the vast distances of space has always been one of the great challenges of astronomy. Unlike measuring distances on Earth, where you can use a ruler, tape measure, or even a car's odometer, space is so immense and empty that scientists have to rely on clever, indirect methods to figure out how far away stars and galaxies really are. When it comes to measuring distances in terms of light years, astronomers use a variety of techniques that combine geometry, physics, and careful observation to map the cosmos. One of the most fundamental methods astronomers use to measure nearby stars is called parallax. Parallax is a concept that might feel familiar if you've ever noticed how objects appear to shift position when you look at them from different angles. Hold your thumb up in front of your face, close one eye, then switch to the other eye, and you'll see your thumb seem to jump side to side. That apparent movement is parallax. Astronomers apply this same idea to the stars. As Earth orbits around the Sun, our viewpoint changes slightly over the course of a year, like shifting from one eye to the other. Nearby stars will appear to move a tiny bit against the background of much more distant stars. By carefully measuring this slight shift in position, astronomers can use basic geometry to calculate how far away those stars are. This parallax method works well for stars up to a few thousand light years away. It's remarkably precise, but limited by the tiny angles involved. The shifts are often smaller than the width of a human hair viewed from hundreds of meters away. To overcome this, astronomers use powerful telescopes and sensitive instruments, like the European Space Agency's Gaia spacecraft, which is mapping over 1 billion stars with incredible accuracy. For stars too distant for parallax measurements, astronomers turn to other tools. One such method involves standard candles, objects in space with known brightness. If you know how bright something truly is, and you measure how bright it appears from Earth, you can estimate how far away it must be. Think of it like seeing a lighthouse from far away. The light's intensity dims as distance grows. By comparing the observed brightness to the known true brightness, the distance can be inferred. Cepheid variable stars are one type of standard candle. These stars pulsate regularly, growing brighter and dimmer in a pattern directly related to their intrinsic brightness. By measuring their pulsation period, astronomers can calculate their true luminosity, then determine their distance from Earth. Cepheids have been crucial for mapping our galaxy and nearby galaxies. For even more distant galaxies, where individual stars can't be resolved, astronomers use other standard candles like type Ia supernovae, powerful stellar explosions that shine with almost uniform brightness. These cosmic beacons allow measurement of distances across hundreds of millions or even billions of light years. Another technique involves observing redshift, which is the stretching of light waves as objects move away from us. The universe is expanding, and distant galaxies speed away, causing their light to shift toward longer, redder wavelengths. By measuring how much the light is shifted, astronomers can estimate how far the galaxy is and how fast it's receding. These methods combine to form what is known as the cosmic distance ladder, a series of steps that extend our reach from nearby stars to the farthest galaxies. Each rung builds on the others, linking different techniques together to create a comprehensive map of the universe. Measuring distances in space is not just about numbers, it's about understanding our place in the cosmos. Every distance tells a story of light travelling across time and space to reach us. It connects us with stars that shone long before humans existed, with galaxies forming billions of years ago, and with the vast, mysterious fabric of the universe itself. When astronomers say a star is 100 light years away, they are sharing the result of careful measurement and deep insight. They are inviting us to imagine a journey of photons travelling steadily for a century, crossing trillions of kilometres to whisper secrets of distant worlds. And so, as you rest and gaze upward, think of the delicate dance of measurement that allows us to connect with the universe. The subtle shifts of parallax, the rhythmic pulsing of stars, the brilliant flash of distant explosions. All these methods help us grasp the vast distances, making the unreachable feel just a little closer. In the silence of the night, as the stars twinkle softly, know that through the patient light they send us, and the careful science that measures their journeys, the universe speaks to us in a language of distance, time, and wonder. When we look up at the night sky, the sheer numbers involved in describing the distances between stars and galaxies can feel overwhelming. Imagine trying to say that a particular star is 546,000 kilometers away. The digits are so long and complex that they blur together, becoming difficult to hold in the mind or even to say aloud. This is exactly why astronomers rely on the concept of light years, to bring order and clarity to the vastness of space, and to help us feel connected to the cosmic distances in a way that makes sense. Using kilometers or miles to measure the distances between stars is like trying to measure the length of an ocean in teaspoons. The numbers become not only unwieldy, but also almost meaningless in daily experience. Our brains, adapted to scales of meters, kilometers, or maybe hundreds of kilometers, struggle with the idea of trillions upon trillions of kilometers. A light year, on the other hand, packages this vast distance into a single, comprehensible unit. It ties together distance and time in a way that feels intuitive. When you hear that a star is 10 light years away, you immediately understand that the light from that star takes 10 years to reach your eyes. You can think in terms of years, something you experience every day, instead of struggling with colossal numbers that defy imagination. This unit brings a human dimension to the incomprehensible. Time is something we all know intimately. We live by its rhythm. We measure our lives in years, months, days. By measuring space in light years, astronomers allow us to think of the cosmos as a living, breathing place, where distances are not just numbers but stories unfolding across time. For instance, when you look at a star that is 1,000 light years away, You're not just looking across distance. You're looking back 1,000 years into history. The light that reaches you today left that star around the year 1025, in a world very different from our own. You're seeing a snapshot of the past, a cosmic time capsule carried by photons racing across space. Using light years instead of kilometers also simplifies communication among scientists and space enthusiasts. Instead of dealing with strings of zeros, they can talk about the universe in terms of years, making it easier to compare distances and to understand the scale of objects. Moreover, the use of light years helps highlight the connection between space and time, a fundamental insight of modern physics. Because light travels at a fixed speed, distance and time become intertwined. Every measurement of distance is also a measurement of how long light has travelled, merging two concepts that on Earth often feel separate. This perspective is important when studying objects billions of light years away. Galaxies at such distances are seen not as they are now, but as they were billions of years ago when the universe was young. Using kilometers would be impractical and would obscure this beautiful connection between light, distance, and time. In addition, light years help frame the challenges of space exploration. Travelling to a star, even a few light years away, would require technology far beyond what we have today. Understanding distance in terms of light years helps us appreciate the scale of these challenges and the incredible speeds that would be necessary to reach other star systems. So the next time you hear a number like 546 quintillion kilometers, remember that it's easier and more meaningful to think about that distance as a number of light years. This not only makes the scale more accessible, but also enriches our sense of wonder and connection to the universe. It invites us to see the cosmos not as an abstract realm of unfathomable numbers, but as a place where time and space are woven together in the gentle dance of light, inviting us to look up, to dream, and to remember that every star we see is telling a story carried on beams of light, travelling patiently across the vast distances between worlds. In this way, light years transform the cold mathematics of distance into a warm, poetic language, one that connects us all, here on Earth, to the vast and beautiful universe that surrounds us. When you look up at the stars twinkling overhead, it might seem like you're seeing them as they are, bright, shining points of light, shining right now in the sky above. But the reality is even more magical and profound. What your eyes are actually capturing is light that has travelled vast distances across space and time. You're seeing these stars not as they are in this very instant, but as they were years, decades, centuries, or even millennia ago. In a very real sense, when you look at the night sky, you are looking back into the past. This happens because of the finite speed of light. Though light travels incredibly fast, nearly 300,000 kilometers per second, it still takes time to cross the enormous distances between stars and galaxies. That journey from the star to your eyes can take years or longer. So the light you see tonight might have left that star long before your grandparents were born, or even before recorded history began. Take, for example, the star Sirius, one of the brightest and most famous stars in our sky. Sirius is about 8.6 light years away, meaning the light we see now left that star over 8 years ago. When you gaze at Sirius, you're seeing a snapshot of that star's past, frozen in time, travelling gently across the cosmic ocean to find you. The star itself may have changed since then, but its light remains a messenger from a moment long gone. For stars even farther away, the time delay grows. The famous Orion Nebula, a stellar nursery where new stars are born, is roughly 1,304 light-years distant. The photons streaming from that glowing cloud began their journey more than a millennium ago, travelling steadily through the vastness of space to reach our eyes. The light from galaxies millions or billions of light-years away carries stories from epochs so distant they border on the unimaginable. This means that telescopes are not just tools to see far, they are time machines. Powerful observatories like the Hubble Space Telescope peer into the depths of space and reveal galaxies as they existed billions of years ago, close to the beginning of the universe itself. Every image from these distant realms is a glimpse into cosmic history, a window through time showing how the universe has evolved. This time delay of light also has an intimate connection to how we understand the cosmos. It's as if the universe is slowly revealing its secrets to us, one photon at a time. Each beam of starlight carries information about the star's composition, temperature, motion, and even about the environment around it. By studying this ancient light, scientists can reconstruct the life stories of stars and galaxies, learning about their births, lives, and sometimes their explosive deaths. The idea that we see the past when we look at the stars invites a deep kind of reflection. It connects us to a vast cosmic timeline that stretches far beyond our own human lifespan. The stars above are not just distant suns, they are storytellers, whispering tales from ages long past, crossing the gulf of space and time to reach us here and now. This also means that when we watch the stars, we are witnesses to the universe's history unfolding in real time, but delayed. In some cases, the stars may no longer exist as we see them. They might have changed, exploded, or faded away, but the light from those events continues on, travelling across the void. Even the light from our own sun is a message from the past, about 8 minutes old. Every second, sunlight reaches Earth, a gentle reminder that even the nearest star sends its warmth and energy through time to nourish life here. This cosmic perspective can deepen our sense of wonder and connection. It reminds us that the universe is vast and ancient, and that our moment here is but a brief point on an immense timeline. Yet through the steady flight of light, we share a profound link with the cosmos, connected across space and time. So as you rest beneath the night sky, allow yourself to imagine the journey of that starlight. Feel the quiet patience of photons travelling through the dark, bridging years and light years to reach you. In those shimmering points of light, see not only distant stars, but echoes of the past, a timeless connection between you and the vast universe beyond. And as your eyes grow heavy and the world slips away, let the stars' ancient light carry you softly through dreams, cradled in the gentle embrace of time and space. Beyond the familiar stars of our Milky Way lies a universe filled with countless other galaxies, each one a sprawling city of stars, gas, dust, and dark matter. These galaxies are separated by mind-boggling distances, measured not just in thousands, but in millions and even billions of light years. Exploring these immense distances brings us face to face with the true vastness of the cosmos and the incredible journeys light undertakes to carry their stories across the universe. Our Milky Way galaxy itself is about 100,000 light-years across. To put that into perspective, the fastest spacecraft humanity has ever built would take tens of thousands of years just to cross from one edge of our galaxy to the other. Yet even this enormous scale is just the neighbourhood compared to what lies beyond. The closest large galaxy to us is the Andromeda Galaxy, located about 2.5 million light-years away. This means the light we see from Andromeda tonight started its journey long before humans walked the Earth in the Ice Age. The photons arriving now have travelled steadily for 2.5 million years, crossing the silent gulf of space at the speed of light to reach our eyes. When we gaze at Andromeda through a telescope, or even with the naked eye under a dark sky, we are seeing a snapshot of that galaxy from millions of years ago, a moment frozen in time. Andromeda is not alone. It is part of the local group, a cluster of over 50 galaxies, including our Milky Way, the Triangulum Galaxy, and many smaller dwarf galaxies. The distances between these galaxies are measured in millions of light years, and yet they are gravitationally bound, slowly moving through space in a cosmic dance that has lasted billions of years. Looking beyond the local group, we enter the realm of galaxy clusters and superclusters, vast collections of galaxies held together by gravity. These clusters can span tens of millions of light years. The Virgo cluster, for example, contains over 1,000 galaxies and lies about 53 million light-years away. The Coma cluster, even larger, stretches across roughly 300 million light-years. As we peer deeper into the universe, telescopes reveal galaxies billions of light-years distant. These ancient light beams carry information from a time when the universe was young, just a few billion years old, compared to its current age of approximately 13.8 billion years. Each photon travelling from these distant galaxies has been crossing space for billions of years, offering us a window into the early cosmos, its formation, evolution, and the birth of stars and planets. Because the universe is expanding, many of these distant galaxies are moving away from us at tremendous speeds. The space between us and them stretches, elongating the light waves in a process known as redshift. This stretching shifts the light toward longer wavelengths, moving visible light into infrared and radio wavelengths by the time it reaches Earth. Astronomers use these redshifts to estimate not only how far away galaxies are, but also how fast the universe itself is expanding. The vast distances between galaxies illustrate why using units like kilometers or miles becomes meaningless at cosmic scales. The numbers become so large they are beyond everyday comprehension. Light years provide a way to translate these enormous expanses into a concept linked to time, a measure that connects distance to the journey light takes. When you consider that the light from a galaxy a billion light years away began its voyage before the first complex life appeared on Earth, or even before Earth itself fully formed, it's clear that looking into space is also looking deep into history. This interplay of distance and time, carried by light, allows astronomers to trace the universe's history, watching galaxies form, collide, and evolve over billions of years. Through powerful telescopes, we can see galaxies merging, stars exploding, and cosmic structures taking shape, all thanks to light that has travelled unfathomable distances. Even more astounding is the cosmic microwave background, the afterglow of the Big Bang itself. This faint light, now stretched into microwaves by billions of years of cosmic expansion, fills the entire universe. It offers a snapshot of the universe, as it was only about 380,000 years after its birth, nearly 13.8 billion years ago. This oldest light is the ultimate messenger, travelling the longest journey imaginable. As you contemplate these immense distances and the galaxies beyond our own, imagine yourself floating among those stars, carried gently on beams of light, crossing millions and billions of light years. Each flicker in the sky is not just a distant point of light. It is a chapter in the universe's story, written across space and time. And as your thoughts drift quietly in the stillness of night, remember that the light you see is a cosmic traveller, journeying for millions or billions of years, connecting us to the universe's vast history and endless wonder. It invites us to dream, to explore, and to find our place in this grand, unfolding story. Light years are not just a measure of distance. They are a bridge between space and time, weaving the two together into a profound cosmic tapestry. When we speak of light years, we aren't simply describing how far something is. We're also speaking about how long its light has travelled, connecting the vastness of space with the flow of time. This beautiful connection between distance and time is one of the most fascinating insights modern science offers about the nature of our universe. Imagine the universe as a grand stage, with every star, planet, and galaxy playing its part across the ages. The light they emit is the messenger, travelling across the dark curtains of space, carrying with it stories from the past. Each light year that separates us from a distant star is also a journey through time, a stretch of years, decades, or even millennia during which that light has been crossing the cosmic sea. This connection becomes clearer when we think about the speed of light as a universal constant. Light always travels at the same speed, approximately 292 kilometers per second, no matter where it comes from or how fast its source moves. Because of this, the distance that light travels in a given time is fixed and predictable. Thus, when we say an object is 10 light years away, we're saying that its light has taken 10 years to reach us. This means every measurement of distance in light years is also a measurement of look-back time. We're literally looking back in time to see the object as it was when the light first set out on its journey. The farther away something is, the older the light, and the further back in time we are seeing it. This intertwining of space and time is at the heart of Einstein's theory of relativity, which tells us that space and time are not separate entities, but part of a four-dimensional fabric known as space-time. The speed of light links these dimensions together, making it the ultimate cosmic speed limit and the thread that ties events together across the universe. For example, when we look at the Andromeda Galaxy, about 2.5 million light-years away, we are seeing it as it was 2.5 million years ago. The light has travelled all that distance and time to reach us, carrying ancient photons that left Andromeda long before humans walked the Earth. So in a way, we are time travellers, peering into a past that predates our very existence. Similarly, the most distant galaxies we observe lie billions of light years away. Their light shows us the universe as it was in its infancy, a cosmic childhood when stars and galaxies were first forming. This gives astronomers a unique window into the universe's history, allowing them to piece together its evolution over billions of years. Even within our own solar system, this connection is present. The sunlight warming your skin left the sun about 8 minutes and 20 seconds ago. So, the light is a message from the sun's recent past, a reminder that even our closest star operates on a timescale slightly removed from our everyday experience. Understanding light years as a fusion of space and time also shapes how we think about travel and communication across the cosmos. Because light takes time to travel, any signal sent to a distant star system will have a built-in delay equal to the distance in light years. If we were to send a message to a star 10 light years away, the earliest reply could come only 20 years later, a fact that sets profound limits on interstellar communication and exploration. This inseparability of space and time also adds a poetic depth to our place in the universe. Each star's light is a journey through time, a beacon from the past illuminating our present. It reminds us that the universe is not static, but a dynamic, unfolding story where distance and time dance together. As you relax beneath the night sky, imagine yourself floating along a beam of light, drifting gently through the cosmos. You are carried not only across space, but through layers of time, witnessing moments long gone, travelling the silent currents of the universe's history. This gentle fusion of distance and time invites us to see the universe not just as an expanse to explore, but as a vast, living narrative, one that connects all of us through the steady, timeless flight of light, carrying stories from the past into the present and onward to the future. Among the most awe-inspiring discoveries in modern astronomy is the detection of the cosmic microwave background, so CMB, a faint, ancient glow that fills the entire universe. This light is not from stars or galaxies, but a relic from the very birth of the cosmos itself. It is the oldest light we can observe, travelling through space for nearly 13.8 billion years, carrying with it a story from the universe's earliest moments. To understand the significance of the CMB, we must journey back to a time long before stars or galaxies existed, to an era just about 380,000 years after the Big Bang. In those first moments, the universe was an unimaginably hot, dense, and opaque soup of particles and radiation. Photons, the particles of light, could not travel freely because they were constantly scattered by electrons and protons. The universe was like a thick fog, preventing light from moving far in any direction. But as the universe expanded and cooled, it reached a critical moment known as recombination. At this point, electrons and protons combined to form neutral hydrogen atoms, allowing photons to finally break free and travel unhindered through space. This release of light is what we now detect as the cosmic microwave background. What makes the CMB extraordinary is that it represents the very oldest light in existence, the first light that escaped when the universe became transparent. The photons we detect today have travelled through the vast expanse of space for billions of years, stretched and cooled by the expansion of the universe into the microwave part of the electromagnetic spectrum. Detecting the CMB was a monumental achievement. In 1965, Arno Penzias and Robert Wilson accidentally discovered this faint, uniform glow using a radio antenna, a finding that earned them the Nobel Prize and provided strong evidence for the Big Bang theory. Since then, sophisticated satellites like COBE's, WMAP, and Planck have mapped the CMB with exquisite precision, revealing tiny fluctuations in temperature that correspond to the seeds of all the galaxies and cosmic structures we see today. The cosmic microwave background is a snapshot of the universe's infancy, a delicate, glowing wallpaper that stretches across the entire sky. Its uniformity tells us about the early conditions of the cosmos, while the slight irregularities reveal how matter began to clump and form stars, galaxies, and clusters over billions of years. Imagine photons that started their journey when the universe was only a few 100,000 years old, travelling continuously through space until they gently brush against the detectors of our telescopes today. These ancient messengers carry encoded information about the origins and evolution of the cosmos. The CMB connects us to the universe's beginning in a way that few other observations can. It's a cosmic whisper from the dawn of time, reminding us that the universe is vast, ancient, and continuously unfolding. Every point of this faint glow is a relic of the birth of everything, the raw energy from which stars, planets, and life eventually emerged. This light travelled over 13 billion years, across distances so vast they are measured in billions of light years. It has crossed the expanding universe, stretched by cosmic expansion, cooling from the fiery birth of the cosmos to the cold microwaves we detect today. When you think about the night sky, consider that beyond the stars and galaxies lies this ancient glow, an invisible light enveloping all of space, silently witnessing the universe's grand story from its very beginning. As you relax and drift into sleep, imagine yourself riding on a beam of this primordial light, journeying through time and space. Feel the immensity of that voyage, from the universe's fiery birth to the quiet stillness of your room. Let the cosmic microwave background cradle you gently, a timeless connection to the origins of everything. This oldest light, carrying the echoes of creation itself, invites you to rest with the universe, joined in a cosmic dance that spans billions of years, weaving past and present together in a glowing, eternal embrace. The idea of travelling a light year, a distance light covers in an entire year, is a fascinating dream that captures the imagination of many who look up at the night sky and wonder what lies beyond. The possibility of exploring other star systems, reaching distant suns, or even visiting planets in faraway galaxies sparks visions of future space voyages and interstellar adventures. But the reality of travelling even a single light year is a challenge of staggering proportions, stretching the limits of our technology, physics, and imagination. To appreciate the enormity of this challenge, consider again the speed of light, approximately 299,792 kilometers per second. This speed is the universal speed limit, the fastest anything can travel in the known universe. Nothing with mass, no spaceship, no person, can reach or exceed this speed, according to our current understanding of physics. The closer you get to the speed of light, the more energy you need, and the effects of relativity make it impossible for anything with mass to actually reach that limit. So when we dream of travelling a light year, we must confront the reality that we cannot move at the speed of light. Instead, we must imagine journeys at a fraction of that speed, and even then, the distances involved mean travel times of decades, centuries, or even longer. The fastest spacecraft humans have built so far is the Parker Solar Probe, which can travel at about 700,000 kilometers per hour. That's mind-bogglingly fast by everyday standards, but even at that speed, it would take over 1,300 years to cover 1 light year. Imagine a journey lasting more than a millennium, pushing the boundaries of human endurance, engineering, and societal continuity. Science fiction often imagines faster than light travel, warp drives, wormholes, or hyperspace, but these remain speculative concepts. They are intriguing ideas grounded in theoretical physics, but not yet feasible with current technology or understanding. Another concept closer to reality is the idea of generation ships, vast, self-sustaining spacecraft where many generations of humans live and die during a voyage lasting hundreds or thousands of years. Such a journey would require a closed ecosystem, reliable life support, and a stable society over centuries, posing profound technical and ethical challenges. In recent years, projects like Breakthrough Starshot have proposed sending tiny, ultra-lightweight probes propelled by powerful lasers to nearby stars like Alpha Centauri. These miniature spacecraft could theoretically reach speeds up to 20% of the speed of light, reducing travel time to decades instead of millennia. However, this approach currently faces enormous technical hurdles, from building the laser array to ensuring the survival and communication capabilities of such probes. Even if we could overcome these challenges, travelling a light year remains a monumental endeavour. The vast emptiness of space, cosmic radiation, micrometeoroids, and the sheer isolation of such voyages create a host of difficulties to address. Communication with spacecraft travelling light years away also presents limits. Signals travelling at the speed of light would take years to reach back to Earth, meaning any response or control would be delayed by the distance itself. Despite these challenges, the dream of travelling a light year, or to nearby stars, continues to inspire scientists, engineers, and dreamers alike. It pushes the boundaries of human ingenuity and encourages us to think beyond our planet and solar system. This dream is also a reminder of our place in the cosmos. While the universe is vast and seemingly unreachable, every step we take in understanding it, every technological leap, brings us closer to these distant horizons. As you rest and let your thoughts wander, imagine yourself aboard a starship, drifting silently through the dark sea of space. Feel the gentle hum of the engines as they carry you steadily forward, year after year, light year after light year, crossing the vast emptiness between stars. Though the journey is long and the distances daunting, the stars wait patiently, their ancient light reaching out across the void. And in those quiet moments of dreaming, you are already travelling among them, connected by the eternal, unyielding light that flows through the universe. As you lie quietly beneath the vast expanse of the night sky, it's natural to feel both a profound sense of smallness and an overwhelming connection to the universe. The stars above shimmer like distant lanterns, scattered across a dark canvas that stretches beyond what the eye can see. Each point of light is a sun, some near, some unimaginably far away. each carrying its own story, its own history, written in beams of light travelling across space and time. You, resting in your place on this small blue planet, are part of this grand cosmic web. The atoms in your body were forged in the hearts of ancient stars, and the light you see tonight has travelled immense distances to meet your eyes. The vast distance between you and the stars is measured in light years, units that not only mark space, but mark time itself. Each light year is a silent journey, a steady flight of photons from distant suns to your presence here and now. The distance between you and the stars is more than physical separation. It is a connection across epochs, threads weaving through billions of years, linking your present moment with events that unfolded long before human history began. When you look up, you are not just looking outward into space, but backward through time. You see stars as they were when your ancestors were distant ancestors themselves, when the Earth was young, and even when the building blocks of life were first forming. This connection to the stars reminds us of the enduring nature of the cosmos and the fleeting nature of our existence. We are tiny in comparison, yet intimately woven into the fabric of the universe. Our lives, our dreams, our stories are all part of a larger tapestry stretching across time and space. Breathing gently, you can feel this vastness settle around you, not as something cold or distant, but as a quiet presence. The universe embraces you softly, with light that has travelled years to find you, whispering ancient tales of creation, change, and continuity. Imagine the slow dance of photons moving through the cosmos, crossing light years of emptiness, touching planets, moons, and finally reaching your eyes. Each photon is a messenger, carrying information about the star it came from, about the time it has travelled, and about the vastness that lies between. Even as you close your eyes and begin to drift into sleep, these silent travellers continue their journey, carrying the light of distant worlds and the echoes of cosmic history. You are part of this continuum, a point of consciousness within the grand expanse. Let this thought bring comfort and peace. The stars above and the light between connect you to something infinite and eternal. In this vast universe, you are both a tiny spark and a vital part of the whole, a moment in an endless flow of light and time. So as you rest, breathe deeply and feel yourself gently carried by the universe's quiet rhythm. The stars watch over you, their light reaching through space and time, a luminous thread binding all existence together. And in this tranquil embrace, you are home, part of the cosmos, part of the eternal dance, forever connected by the light that travels, unceasing and patient, across the vast distance between you and the stars.